In this video, we're going to solve by factoring. We have solved by factoring in the last unit, but this includes all polynomials and factors. And so let's just review with a couple factoring problems. So 25x to the fourth minus 36 is actually a difference of perfect squares. You can get 25x to the fourth by multiplying 5x squared times 5x squared. And then you can get 36 by taking 6 times 6. Since the middle equals 0, one will be positive and one is negative. So difference of perfect squares, 5x squared plus 6 and 5x squared minus 6. Over here on B, it looks like it is possible that it is a perfect square trinomial. So let's try and see if we can get this to work out. So actually, looks like each term has a b squared, so we're going to take that out first. And then dividing them all by a b squared, we're going to be left with a squared minus 8ab plus 16b squared. Now it's a perfect square trinomial, so b squared, then you get a squared by a times a, and 16b squared is 4b times 4b, and since it adds up to negative 8 in the middle, you need both of these to be negative. So we could multiply that back out just to check. So a minus 4b times a minus 4b. So a times a is a squared. A times 4b is 4ab. Negative 4b times a is negative 4ab. And negative 4 times negative 4b would be positive 16b squared. And then you'd combine like terms and you would get the negative ab. So that would in fact be the answer for that one. Okay, so factoring and solving. So solve for all solutions. So that includes imaginary and real solutions. And the fundamental theorem of algebra tells us that the degree of the polynomial is the number of solutions that it has. So this one is a degree, the first one here is a degree of 4. It is quartic, which means that it will have 4 solutions. So we can solve for these solutions first by factoring. So I'm going to take out a greatest common factor of 2y squared. And that'll leave me with a y squared minus 9 if I divide them both by 2y squared. And then I can continue to factor because y squared minus 9 factors to y plus 3 and y minus 3. And then solve by factoring, set each factor equal to 0. And solve. So this one we divide by 2 and we get y squared equals 0 divided by 2 is 0. Square root y equals, technically it's plus and minus 0, so it is 2 answers there, but both positive and negative. 0 is just 0. So that's 2 of our answers, 2 zeros. And then this one subtract 3 and we get y equals 3. And this one add 3 and you get y equals, this one's negative 3, and then this one is y equals 3. So there's our 4 answers. Technically 0 is an answer for 2 of our y's. Okay, the second one here, x cubed minus 27. This is a difference of perfect cubes, an a cubed minus b cubed. So this is going to factor to a minus b times a squared plus ab plus b squared, where a where our x cubed, and then 27 is 3 cubed. So we're going to let A be x and B be 3. So A minus B will be x minus 3, and then A squared will be x squared plus A times B would be x times 3, so 3x, and then plus B squared, so 3 squared is 9, and equals 0. So then we can set each factor equal to 0, so x minus 3 equals 0, or x squared plus 3x plus 9 equals 0, and solve. On the left we add 3, and we get x equals 3. And then for this side, since I can't factor it anymore, and I know I can't factor it anymore because nothing multiplies to 9 and adds up to 3, so you could either solve by completing the square, solve by the quadratic formula, or that's it. So I typically do the quadratic formula. So just as a reminder, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a, where a is 1, the 3 is b, and the 9 is the c. So x equals negative b plus or minus the square root. B squared minus 4 times 1 times 9 all over 2 times 1. So reducing that, we'll have negative 3 plus or minus the square root. Inside the square root, I had 3 squared is 9. Negative 4 times 1 is negative 4 times 9 is negative 36. 9 minus 36 is negative 27 all over 2. And then I can reduce this. The square root of negative 27 is the square root of negative 9 times the square root of 3. So it is, you can take out the 3. The square root of negative 9 is 3i. So negative 3 plus or minus 3i square roots of 3 all over 2. So that is our other two answers. So for the second problem here, we have x cubed, so we have 3 answers. We have 1 real answer and then 2 imaginary answers. We have negative 3 plus the square 3i square roots of 3 over 2 and negative 3 minus 3i square roots of 3 over 2. So 3 total answers there. Okay, so one thing to mention before I get too far is if we would have took this and solved x cubed minus 27 equals 0, and we would have just added 27, and then we took x cubed equals 27, we took the cubed root, you would have gotten x equals 3. That is just the one real solution. That's why we factor it, so then we can solve the second piece here by the quadratic formula, and then we get all the 3 solutions. So if you just solve by roots, you only get 1 solution when there should be 3. Okay, solving this one on the left here. So to solve by factoring, we do know that we want to have it equal to 0, so I'm going to start by subtracting the 18. There are no like terms here, so it's just x cubed plus 2x squared minus 9x minus 18. Since there are 4 terms, It is a factor by grouping problem. So group the first two and group the second two. Then take out the greatest common factor from each group. So x cubed plus 2x squared, you can take out an x squared and then divide both of these by the x squared. I'm going to get x plus 2. Then in my second group, I'm going to want to take out a negative 9 since both are divisible by 9. And I want what's left to be x plus 2. So I'm going to take out the negative and the 9. So that when I divide this by negative 9, I get x. And when I divide this by negative 9, I get 2. And then I have two terms here, this term minus this term. And both of those terms have an x plus 2. So take the x plus 2 out front. And then if I divide the x plus 2 out, I have an x squared minus 9 left. Now x squared minus 9 does factor one more time. X plus 2 times x plus 3 times x minus 3. So we'd get three answers. X would equal negative 2 if you set that equal to 0, because remember it'd be x plus 2 equals 0, so x would equal negative 2. X plus 3 equals 0, so x would equal negative 3. Or x minus 3 equals 0, so x would equal positive 3. This was a cubic function, and we got three answers. So three real answers there. Technically, since this is a perfect or a square right here, you could have solved by square roots. X squared minus 9 equals 0. Add 9, get x squared equals 9. Square root x equals plus or minus 3. So in this particular case, you could have stopped right at this step and solved by square roots and solved by factoring from there. But in general, try to factor it down as far as it can go. Okay, so this one we're going to start by getting it equal to 0. So I'm going to move that 81 over. And then 16 and 81 are perfect squares, so is x to the 4th. So the first way it factors is going to be 4x squared minus 9 and 4x squared plus 9. So perfect squares in both. So this one technically factors more to 2x plus 3 and 2x minus 3. But you could just, since you're solving, you could set these quadratics equal to 0 now and solve, either by quadratic formula or square roots. So I can solve by square roots if I add 9 to both sides, and then 4x squared equals 9, divide by 4, get x squared equals 9/4. Take the square root and square root the fraction, the top and bottom separately. Going to get plus or minus, the square root of 9 is 3, the square root of 4 is 2. So there's two answers for this quartic polynomial, 3/2 and negative 3/2. And then the other side, you subtract 9, you get 4x squared equals negative 9, divide by 4, get x squared equals negative 9/4. Take the square root of both the top and bottom, and you'd have x equals plus or minus, square root of negative 9 would be 3i, and the square root of 4 is 2. So there's our other two answers, positive 3i over 2 and negative 3i over 2. So four answers for that quartic polynomial there. Okay, last one. So 8x cubed and 125 are perfect cubes. So 8x cubed is the same thing as 2x to the 3rd. And 25 is the same thing as 5 to the 3rd. So I have an a plus b, a cubed plus b cubed situation here. And in which case it factors to a plus b, and then it's a squared minus ab plus b squared. So if it's plus, then the plus sign comes first and it goes plus minus plus. Otherwise it's the same as the minus one. So a plus b is 2x plus 5, and then it's a squared, so this time it's 2x squared minus a 2x times b, 2x times 5, plus b squared, 5 squared. So simplifying that out, 2x plus 5, 2x squared is going to be 4x squared, 2x times 2x, minus 2x times 5 is 10x, and then plus 5 squared is 25. Set both equal to 0 and solve. 2x plus 5 equals 0, or 4x squared minus 10x plus 25 equals 0. The left side I can solve simple linear equation, 2 steps. Subtract 5 and then divide by 2. Excuse me. And then in part B, you're going to have to use a quadratic formula again. You're not going to want to complete the square since a is 4 here and it's not factorable. So quadratic formula it is. A, B, and C. And almost always with, and not always, but a lot of times with these perfect cube equations like this, is you'll get one real solution and 2 imaginary solutions. Not always, but a lot of times. So it's x equals negative b, so it'd be negative 10, so positive 10, plus or minus the square root. B squared would be negative 10 squared minus 4 times a is 4 times c is 25. All over 2 times 4. So that's going to be 10 plus or minus the square root. 10 squared is 100, and negative 4 times, well, I'm going to do 4 times 25 is 100 times negative 4 would be negative 400, all over 8. So I'm going to have 10 plus or minus the square root of negative 300 over 8. Let's see, 30 times 10. 10 times 3. So I could keep going, but I have a pair of 10s here. So I'm going to take that out, and it was negative. So I'm going to say that's 10i, and then square roots of 3 left over. So basically 300 is 100 times the square root of 3, and the square root of 100 is 10. All over 8. And then 10, 10, and 8 are all divisible by 2. So 5 plus or minus 5i, square roots of 3, all over 4 should be my final answer. So 2 solutions there, and then 1 other solution gives me my third solution. Okay, that was a lot. Hopefully you followed along okay. Thanks for watching.